Now in this session, unit 3 is divided into two parts. So first part is the feedback concept and second part is the oscillator. Already we have discussed the feedbacks. Now in this session we are going to discuss about the oscillator. Now what is an oscillator? Oscillator is an electronic circuit which converts DC to AC signal. Now I will compare this oscillator with an amplifier. Now this is an amplifier block diagram, this is the oscillator. In this amplifier already we have studied in the unit 2. Here we are giving the input AC signal and also DC signal, that is nothing but a plus VCC. We have studied in a CE amplifier, we have given the plus VCC, DC voltage we have given. So both DC we are giving and AC also we are giving, thereby what? Amplifier amplifies, strengthens the signal and it gives the AC signal at the output. Now coming to the oscillator, it is almost like an amplifier only, but here input signal is absent. We are not giving any input signal. This DC is converted into AC signal in the case of oscillator. Now this is the main difference between oscillator and amplifier. Oscillator is a generator which will produce the oscillations. Now here we will see the classifications of oscillator. There are so many different types of classifications are there, but specifically here I am giving the classification based on the waveform, if it is sinusoidal waveform or not. So first one is about sinusoidal oscillator. The output which generates the sine waveform. So sinusoidal is nothing but what? If the output is the sine waveform, then this is a sine waveform. Then that is those oscillators which generates the sinusoidal waveform, those oscillators are called the sinusoidal oscillators. Now coming to the non-sinusoidal oscillator means output which is output if not, this is not the sine waveform. For example, square, triangle, ramp, if pulse, those are all comes under non-sinusoidal waveform. Now next again sinusoidal waveforms are classified into 4 different types. Here you can see a tuned circuit means what? If the oscillator, if we are using L and C values, if we are using L and C values, then those are called the tuned circuit oscillators, and if we are using R and C values, then those are called the RC oscillator. Now these LC circuits or LC oscillator we use to generate the high frequency, and RC oscillators we use to generate the low frequency. And the next one is a crystal oscillator. Now here the quartz crystal is used to generate the oscillations. Now here it will produce the highly stabilized output signals. Output will not vary, so it will give the stabilized output. Now coming to the negative resistance oscillator. Now the devices which is having the negative resistance property, for example tunnel diode. Now if you take the tunnel diode, so which is having the negative resistance property, without applying feedback automatically the device will generate the oscillations. Now these are the 4 different types of oscillations, and few other oscillators are also there based on the mechanism, based on the, now here also I have explained the component based on the frequency, audio frequency, radio frequency, VLS, very large frequency, medium frequency, like that. So many other types of classifications are also there, but here I have specified the, now these we are going to study under the oscillator chapter, LC, RC, crystal. Now these are the oscillators we are going to study in this oscillator. That's why now here I have given these classifications. Now coming to the waveforms, now here we have 2 types of sinusoidal waveforms are there. One is a damped oscillations and another one is a undamped oscillations. Means what? In the damped oscillations, the amplitude is reducing with respect to time. As the time is increasing, the amplitude is reduced. Now coming to the undamped oscillations, here if you see with respect to time, the amplitude is constant. Now this is called the undamped oscillations. Now these 2 are the different types of sinusoidal waveforms. Now coming to the already this now principle of positive feedback amplifier, this already we have derived the feedback gain with feedback expression already we have derived in the feedback concepts. Now if I am applying the positive feedback, means what? Part of the output is fed back to the input is called the feedback. Now where this feedback signal is in phase with the input signal, then we call it as a positive feedback. Now in this case Vi is equal to Vs plus feedback signal. Now in the feedback concepts we have seen the negative feedback. In the oscillator we use the negative feedback, but in the in the amplifier we use the negative feedback, but in the oscillator we use the positive feedback. Because of this positive feedback concept only, oscillators will generate the oscillations. Now here Vi is equal to Vs plus Vf. Now if we derive this expression, already we derived in the feedback concepts. Now once again I am giving the expression for AF. AF is equal to what? A divided by 1 minus A beta. If we derive the gain with feedback, then we get the expression AF is equal to 1A by 1 minus A beta. Now if this A beta is nothing but what? Loop gain. A beta is loop gain. If this gain is equal to unity, loop gain is equal to 1, then this oscillator, this amplifier will give the infinite gain. So now if this is equal to 1, then gain is equal to nothing but what? Infinite. So A divided by 0 is infinite. So because of this infinite gain, so this oscillator produces the oscillations. Now how oscillator works, what is the block diagram of that? Now let me explain the next slide. Now before going to discuss about the block diagram, now let me explain the Barkhasan criteria or conditions for oscillations. Now an electronic circuit, when it will generate the oscillations, means it has to fulfill the two conditions. One condition is, first condition is loop gain A beta, magnitude of loop gain must be 1, then only circuit will generate an electronic circuit will generate the oscillations. And one more condition is, now here the phase shift around the loop must be 360 degrees or 0 degrees. Is nothing but what? A positive feedback. Now 360 or 0 degrees means what? It is in phase. Whatever the feedback we are applying, that is in phase with the input signal. So that is nothing but 360 degrees or 0 degrees. If these two conditions are satisfied, then only the circuit or oscillator circuit will or an electronic circuit will generate the oscillations. Now here for these two conditions we can also call it as Barkhasan criteria or conditions for oscillations. Now this is the block diagram for the oscillator. Now in the oscillator, what are the major components? Means first one is an amplifier. We are using an amplifier and we are using the positive feedback network. Now now here we are using the transistor, some capacitors, resistors. Now internally, one oscillator, when we switch it on, then it will, now internally some noise will be generated. So that noise will be amplified and again it will be fed back to the feedback network. Already in the positive feedback we have discussed that gain is infinity. So with that what? The signal will be further amplified and we get the oscillations at the output. Now this circuit, now when the amplifier is, now in the amplifier, if it is switched on at the starting, within the short time, the gain will be increased to infinite, thereby what? Output voltage will be increased to infinite. So that will introduce the non-linear effects in the amplifier. So with that what happens? Now it will now here the gain is going to, now here the changes, modifications from the base to collector and collector to base will be unity, thereby it will generate the undamped oscillations at the output. Undamped oscillations means what? Gain magnitude is constant. If now when we set the A beta is equal to 1. Now if because of the temperature effects or so many components we are using, so specifications of the components may vary, therefore we can't maintain the A beta exactly 1 sometimes. So here it will go low or sometimes it will go high. So here to produce the oscillations, always we have to keep this A beta is greater than or is equal to 1. At that time it will give the damped oscillations. Now or otherwise amplitude, if the gain is increasing it tends to infinity, then the amplitude also it will not maintain constant. Amplitude may also increases. So to maintain the amplitude constant, we need an external amplitude limiter. If the circuit itself is introducing the nonlinear effect and then thereby if it is controlling the amplitude, then we don't need any external amplitude limiter. If the gain is increased, a beta factor is equal, loop gain is greater than or is equal to 1, that time what? Amplitude may increase with respect to time. That time we need an external amplitude limiter to control the output voltage. Now this is about the block diagram of oscillator. Now main components are, main blocks of the oscillator is what? Amplifier and feedback network. Now here we will see how the sinusoidal waveform set up in a LC. If I am taking the tank circuit, then how the LC circuit set up the oscillation, we will see now. Here I am taking one inductor in parallel with one capacitor. Now initially capacitor is charged to the maximum by using the external battery. So now it set up the voltage like this, positive at the top and negative at the bottom. And after charging the capacitor maximum, if I close the switch, then if no current is coming into the capacitor, means what the capacitor will try to? Capacitor will try to discharge. Now in this path it will discharge. Now here electric field will develop. Now here electric field develops in the inductor. Now capacitor discharges completely, and because of the Lenz law, now what Lenz law, in which direction the current is entered into the inductor, in the same direction the inductor will discharge. Now after discharging the capacitor, now here electric field setups, and after that if no current is coming, then this inductor will try to discharge. Now in which direction it will discharge? In the same direction it will discharge because of the Lenz law. So negative EMF will be produced, and that will discharge in this form. Thereby what? Now the capacitor again it will charge like this. It will charge positive over here and negative on the top. So after completely discharging the inductor, now capacitor again charged. So if no current is coming from the inductor, after completely discharged means what? No current is coming from the inductor. At the time again capacitor try to discharges. Now in which direction it will discharge? Now here negative is there. So in this direction it will discharge. So thereby what? Electric field will set up across the inductor in the opposite direction. Now in this direction. Now after completely discharging the capacitor, now again here the inductor will try to discharge. In which direction? Again in the same direction in which direction the current flown through the inductor. Now this is because of the Lenz law. Now if you see here, at the beginning capacitor is charged, now positive and negative here, and after discharging again when the capacitor is charging, it is charging in the opposite direction. Now here again it is discharged, and when the inductor is discharging again capacitor will charge in this direction. So now here again on the top it is positive and at the bottom it is negative. Now if we try to observe the output voltage across the capacitor or voltage across the inductor, if we try, then it will look like this. Now one time it is going up and one time it is going down. Now thereby what? It is producing the oscillation, sinusoidal waveform across the capacitor. Now this is the basic principle behind the oscillator. Now when we are using L and C values, so because of the charging of the capacitor and discharging, both charging and discharging of L and C values, it is set up the oscillations. So this is the basic concepts of LC circuit. Now in the next lecture we will see the now here in the next slide. Now this is the general form of an LC oscillator. Now here we have two types of oscillator. Now in your syllabus we are studying the three different types of oscillator. One is LC oscillator, and another one is a RC oscillator, and the third one is a crystal oscillator. So these three oscillators we are studying in the oscillator unit 3 oscillators. Now here this is the block diagram for the LC oscillator. Now we have an amplifier, and this is the tank circuit or tuned circuit. In this tuned circuit we are using the Z1, Z2, Z3, 3 components we are using. Those are nothing but what? L and C values we are using. Z1, Z2, if both are L values, now here if it is, this is L value and this is also L value, and if it is a C value, now this oscillator is called the Hartley oscillator. Now if the Z1 and Z2 both are C value, capacitor value, and Z3 is a L value, now this is called the Colpitts oscillator. Now these two oscillators we are going to study in the next lecture.